Why is the P pump important to you? Because you'll find it in so many applications. This dumper mixer by Mack and many other heavy-duty vehicles. In construction, farm equipment, and heavy-duty trucks by International Harvester. In farm and industrial equipment by John Deere. Well over 100,000 P pumps, serving many well-known names. Some of these pumps will need repair and testing service to perform the pumping jobs, pressurize the fuel, time the delivery, meter the quantity. When you service the engine, repair and test the pump. You'll get the job done easier and faster if you know what happens inside, how your measurements and adjustments affect the operation of the P pump. Of course, this pump can be controlled by different kinds of governors. No matter what kind of governor, it comes down to how the control rack is positioned to turn the sleeves and plungers. We'll cover that later. You may find yourself repairing inline P pumps, even a V8. The 6 is widely used. They're really quite similar in the way they pressurize the fuel. How is this done in the pumping elements? To pressurize, begin with a plunger, on a roller tappet assembly, on a cam. Your cam may have a broad lobe like this. A broad lobe cam is called a non-reversing cam. Compare it to a narrow cam lobe. In servicing, when you rotate the camshaft, you can usually tell the difference. Whatever the shape of the cam lobe, your plunger mates with a barrel in an assembly. At bottom dead center, fuel from the port at supply pump pressure fills the barrel. We'll show that in orange. Now, as camshaft rotation begins to lift the tappet and plunger, like this, does that pressurize the fuel for delivery? No. The port is still open. Fuel is still at supply pump pressure. Only after the plunger lifts to port closure does it begin to build high pressure for delivery. We'll show that in red. On a graph, you can see this same idea, how the plunger lifts in its stroke from BDC to port closure, shown in orange, and then begins delivery of pressurized fuel through the delivery valve. As you know, fuel is injected into the cylinder for compression ignition. When you understand pressurizing the fuel, you'll understand the first job of the pump. You know the second job of the pump, time the fuel delivery. That depends on how you set port closure. You should be able to picture it in your mind. When your plunger is lifted by its tappet to port closure, that determines when injection will begin. Your basic timing is set on cylinder number 1 according to the spec sheet. Suppose for a given camshaft rotation, you don't yet have port closure. What could you do? In principle, the plunger could be raised or the port could be lowered. In the P pump, you'd lower the port. How would you do that? Under these flanges, a set of shims determine the position of the barrel up or down. When the barrel port is like this in relation to the plunger, that sets up port closure. In most P pumps, you'll find a series of one-piece shims which can be stacked to adjust port closure. In other P pumps, split shims can be changed without removing the barrel. When the cam lobe lifts number 1 plunger to the specified lift and the barrel is shimmed to port closure, you have timed number 1. Considering that as 0 degrees for a starting point, what do you need for correct phasing? Port closure of the other pumping elements at equal intervals in the firing order, 60 degrees in this case. Each plunger will rise to the same specified lift as the camshaft is rotated to equal intervals. Number 1 is the reference when it is set to port close at the specified lift. When rotated to equal intervals, other plungers will have the same lift. so each of the other barrels is adjusted with shims for port closure. When each cylinder is timed to port close at equal intervals, matching the specified lift of number 1, the pump is phased. Sometimes this is called internal pump timing. When you've done it right, timing can deliver pump performance that pays off in many ways. You've set your pump to properly pressurize the fuel and properly time the injection, taking care of the second job of the pump. The third job of the pump is to meter. Metering sets up the quantity of fuel delivered. As you know, metering is done by changing the effective stroke, by changing the port opening as the plunger lifts at high pressure from port closure. You may recall how the helix changes port opening. When the control edge of the plunger helix uncovers the port, pressure falls to supply pressure, shown in orange, and that stops delivery of fuel. For smaller plungers, a single helix does the job. But for larger plungers, a double helix with 2 ports handles a greater quantity of fuel. Whatever the helix, in the P pump you'll find a baffle sleeve around the barrel. When high-pressure fuel first spills, this sleeve keeps fuel from striking and eroding the aluminum pump housing. As on all pumps with a helix, when the spill happens sooner, as on the left, you have a shorter effective stroke. Compare that to a later spill, which gives a longer effective stroke. When do you want the shorter effective stroke and less delivery? Yes, at low idle. You want the plunger helix turned this way, so the helix will spill sooner for a shorter effective stroke. And turn the other way for starting. The plunger lifts more. The helix spills later, so a longer effective stroke. Suppose for easier starting, the engine needs a change in the timing of the injection. Change the timing as well as the quantity. You might find a plunger with a retard notch like this. With this plunger turned for starting, think about what happens to the timing. The retard notch is turned to the port. So, when the plunger rises in its stroke, port closure takes place later than it would if the notch were not here. On the graph, compare the starting port closure, which happens later than port closure at other times. When you think of the rack turning the control sleeve and plungers, you think of metering. As you know, pump rack position is determined by the governor. That, in turn, is changed by the operator's movement of the control lever and by the RPM. When you take a draw on the pump, you're measuring the quantity of fuel delivered for a certain rack position. The closer the spread, that is, the differences in draw among the cylinders, the smoother power the engine will deliver. How do you close the spread? You change the port openings. When any barrel is rotated, the port is turned in relation to that helix. Let's see how this changes delivery. If the barrel port is rotated like this, the plunger will lift farther and deliver more fuel before port opening. On the other hand, rotating the port the other way will cause earlier port opening and deliver less fuel from that pumping element. When you balance the P pump, you set equal delivery by rotating each barrel individually. If you were rotating this barrel this way, would you be adding delivery or reducing it? Yes, adding delivery to a cylinder that was low. And when you cut back on the cylinders that were high, you have reduced the spread. You have completed balancing the delivery. To summarize barrel adjustments, raising the barrel port delays port closure. How do you do that? With shims. Remember the two steps in phasing, internal pump timing? First, shim number 1 to port close at the specified lift. Second, shim the others to port close at equal intervals. In contrast to port closure, port opening is adjusted by rotating the barrel port to adjust the metering. Rotating this way delays port opening. You have completed balancing when you have rotated each barrel to port open with equal deliveries within specs. When the rack travel causes the plungers to turn in the adjusted barrels, you know what will happen. Your pump will check out on the test bench at the specified pump speed and rack position. Equal delivery within specified limits. Equal delivery at the high RPM, full load, which means later port opening. Equal delivery at low RPM, as if at light load, which means earlier port opening. The kind of pump performance that customers want. From the P Pump, brought to you by BOSCH.